Hi boys and girls, back again today for another math lesson. Okay, today our learning target is I can locate a given point on the number line greater than 1. Last week we talked about fractions that were on the number line and they fell between 0 and 1. In other words, they were less than 1. Today we're going to talk about fractions that are greater than 1. And those fractions have a really special name that we're going to learn about today. So let's take a look. We're going to go back to our all very familiar shape, the circle. We've worked with the circle last week and at other times. And last week we partitioned our circle in half. Okay, this part is half, this part is half, this part is half of that circle, and this part is half of that circle. Now, I'm going to actually shade as best I can 3 parts of these circles, of these halves. Now, what you're looking at right here, I've shaded 1, 2, 3 halves. So let's look at what that looks like in a fraction. 3 halves. Now, that's a little different than what we've been seeing. Normally, the number on the bottom, or our denominator, is larger than the number on the top, our numerator. When that happens, this type of fraction has a really special name, and it's called an improper fraction. An improper fraction. Okay? That's really important. You need to know that. You will hear that word, an improper fraction. And an improper fraction is when the numerator is bigger than the denominator. Now, back to our circles. And we know that we have 2 circles here, and we've shaded 3 of the halves of our circles. So let's look at how we would put this on a number line. Okay, so first of all, let's make our number line. Now, remember we use hash marks to mark off our number line. So first of all, I'm going to start right here where my line begins, and I'm starting at 0. Okay, now I know that I can see I have 1 whole circle, so I for sure know that I am going to go to 1. Okay, so I'm going to mark my number line to 1. But then I also have another circle that I need to include. So in other words, I have 2 circles. So my number line needs to count to 2. And we know that we can count more than 1 or greater than 1. We know that we can count to 2 and to 3 and to 4. So obviously I can see I have 2 circles here. So I'm going to mark that off. Now, let's look at how do we actually plot or partition this number line to show this fraction, 3 halves. We can see 1, 2, 3 of the halves of the 4 that make up these entire 2 shapes are shaded, so I need to show that there are 3 shaded. Okay, so first of all, this number, my denominator, tells me what I'm going to partition my number line into. I'm partitioning it into halves. Just like I partition my circle into halves, I'm going to partition my number line into halves. Okay, so I'm going to partition my first space, or my first area here. Okay, and then I'm going to partition my second area in half. Okay, so let's talk about how we name this. So I can see when I have 0, I have nothing there. There are 0 halves. Okay, if I move over to my next hash mark, I have 1 half, and I can see there's 1. I'm going to move over to my next hash mark, and I have 2 halves. Okay, and then that would mean my shape is whole. So there's 1 2 halves. I have 1 whole circle. Going back to my number line, I'm going to look at my next hash mark, and I have 3 halves. Okay, so 1 2 3 halves. Don't forget, I partitioned this part of the number line from 0 to 1.5, and then this part of the number line in half from 0 to 1. So we just keep on counting, and we're still dealing with halves because this is broken half and this is broken half, partitioned in half. Okay, and then keep on going, and we have 4 halves. Now, how do we find where 3 halves is? We see that it's right here. Okay, 3 halves.